So I'll just rewrite the question first. It says question number 9. Question number 9 says x to the power 3 over 2 minus 1 times x to the power minus half plus 1, right?
Yes, sir.
Okay, so
What
first I
I had.
multiplied 3 over 2 plus half will be 3 over 2 minus half. It will be 1 over 2 x to the power 1 over 2. Then x to the power 3 over 2 times 1. I get x to the power 3 over 2 as it is. Then minus 1 into x to the power minus half gives me minus x to the power minus half, and then minus 1 times plus 1 gives me plus 1. 3 over 2 minus 1 over 2, it won't be half, it would be 1. This first one I wrote wrong. This over here, this would be 1. Okay,
Okay, sir.
that was the thing
Oh wait.
that I also thought you got wrong. 3 over 2 minus half, that would be 1. This
Oh
part,
right, because you're adding. I
it's
multiplied it by accident.
minus 1 over 2, and since the terms are multiplying basis, the same powers were dead, so I'll get x to the
Yes.
power 1 over here. So this is what I'll get, x to the power 1 plus x to the power 3 over 2 minus x to the power minus half and minus 1. And then the next part of the question says curve has this equation the same as the one given before. You have to find dy by dx, so we will find this is y. Now to find dy by dx, for x dy by dx will be 1. For 3 over 2 x to the power 3 over 2, it will be 3 over 2. X to the power 3 over 2 minus 1 will be half, x to the power half, minus minus it will become plus 1 over 2, x to the power minus half minus 1 will be minus 3 by 2, and for this one it will be 0.
Hmm.
Understood?
Okay, sir.
Any confusion
Yeah.
in this part?
No confusion. That's I just messed up a little bit in the first part where I just had
Hmm.
multiplied
Hmm.
instead of adding them together, which is a dumb mistake on my part. But the
Hmm.
differentiation part afterwards, I understand how to do that.
So now you have got the same dy by dx as what I've written over here.
Yes.
All right. Then the next part, so this will be dy by dx, that would be the answer for part B. For part 3, we have to find the equation, sorry, we have to calculate the gradient of the curve at point where x is equal to 4. So in this same equation, I'll say dy by dx when x is equal to 4 would mean dy by dx is equal to 1 plus 3 over 2 into 4 to the power 1 over 2, which is square root of 4, plus 1 over 2 into 4 to the power minus 3 over 2 plus 0. So that's it. And what do I get as answer for this thing? This would be 1 plus 3 over 2 into 2, root of 4 will be 2, plus 1 over 2 into root of 4 cubed. So root of 64, which should be 8, which would multiply with 2 to become 16. So 1 plus 3 plus 1 over 16. 4 whole 1 by 16. That is the gradient of the line, that is the gradient of the curve when x is equal to 4. Gradient of curve when x is equal to 4. Understood?
Yes, sir. That's not right. Yep.
Noted.
Mm-hmm.
Next question. All right. Mm, this I'll need to remove. Question number 10. Differentiate with respect to x. So you have to do simply the differentiation. Go ahead.
Differentiation respect to okay. Beta, two, two, x, plus, which is x squared minus x squared that would cancel out, and plus 2x minus two x to the power of 1 plus 2. If we differentiate to be 2 times 3, which is 6, x squared plus 1 multiplied by 0.5 would be 1 over 2, x power of minus 1 over 2, plus minus 1 here to be minus 2, x to the power of minus 2. And then the 1 just cancels out because not in the respective axis. That's the differentiation that we're getting. And then what do you do afterwards? Do you just keep it like that? That's the answer, sir.
You can keep it like that, or you can say, give it a bit decent form, 2 over x squared. So like this is good, like this is good, equally fine. Done. Next question.
Yeah. The curve of the equation y is equal to ax squared plus bx plus t passes to the point 1, 2. The gradient the curve is 0 at the point 2, 1. Find the values a, b, and c.
How do you do this one? The
Need to
gradient
find
is
the
0. Hmm.
Okay, so to do that, I would do y is equal to mx plus c and make m is equal is 0, and then I would have my y and x by 2 and 1.
Y
I
is equal
find
to
what my
mx plus c. Why would you do that?
I can find because I can find the
See,
constant
see.
c.
Aim of the question is to find values of a, b, and c. In order to find values of a, b, and c, I need to get 3 equations in terms of
Yeah.
a, b, and c. Ideally, which would get me the answer of all 3. So let's see what are the points through which the curve through which the curve passes through. So first point given is 1 comma 2. So I know y is equal to ax squared plus bx plus c, and the curve passes through the point 1 comma 2. So I can put that value of x and y over here. So I can say 2 for 1 comma 2, it will become 2 is equal to a into 1 squared a plus b into 1 will remain b plus c. So a plus b plus c is equal to 2. That's my first equation.
Okay.
Okay, I call this equation 1. Then I am told that this curve also passes through, because the gradient of the curve is 0 at point 2 comma 1. If it becomes 0 at this point, it means it's also passing through this point. So for point 2 comma 1, now I will say 1 is equal to a into 2 squared will become 4a plus b into 2 will become 2b plus c. So 4a plus 2b plus c, this is equal to 1. Okay,
Okay.
this is my
Second equation.
second equation. For the third equation, I am told that the gradient of the curve becomes 0 at this point, so I'll write
dy over dx
y
is
is
equal to
equal
0.
to ax squared plus bx plus c. So dy by dx will be equal to 2ax plus b, right? And 2ax plus b, it becomes 0 at when it is passing through 2 comma 1. At 2 comma 1, dy by dx is equal to 0. So dy by dx I'll put equal to 0, 2a, and instead of x I will put 2 plus b. Understood?
Mm-hmm.
Or is this confusing? You don't understand how I put the value of 2 over here. When dy by dx is 0, the value of x is 2. So I put this value of x in this dy by dx.
Okay. Yeah.
Instead of 2ax, I put 2. Alright. So this gives me 4a plus b is equal to 0. 4a plus b is equal to 0. This is my third equation.
Okay.
Hmm. Hmm. Now if I take the first two equation and I subtract the first equation from the second one. So I write over here subtracting 1 from 2. So right hand side I'll subtract from right hand side, and left hand side I'll subtract from left hand side. So first I write equation number 2, which is 4a plus 2b plus c minus a plus b plus c. This is equal to 1 minus 2. Any confusion in this step?
No.
4a minus a gives me 3a. 2b minus b gives me what? Plus b. Plus c minus c gives me 0. And 1 minus 2 gives me minus 1. Okay. Hmm. Are you there? Following me?
Yes, sir. I'm writing. I'm just trying to write it down. Done.
Okay. And if I subtract, let me call this equation 3, and then sorry, equation 4. I have already got an equation 3. This is the fourth equation. So I say subtracting 4 from 3. So if I subtract 4 from 3, it would mean 4a plus b minus 3a plus b is equal to 0 minus 1. 4a minus 3a is a, b minus b would cancel out, so a is equal to 1. Any confusion?
Nope. No confusion.
Then I put a in 3, so I get 3
B.
into 1 plus b is equal to minus 1, so 3 plus b is equal to minus 1, and b is equal to minus 4. Alright,
Okay, sir.
and
And then you
now
just
I
put those
put
equations back into number one, or
in
you
number
can work
1.
with any equation.
Any equation would do, but since I'm looking for c, I'll put it 1. Put a and b in 1. So 1 says 4a, 4 into 1 will remain 4, plus 2b, 2 into minus 4 will become minus 8, plus c is equal to 2. So 4 minus 8 is minus 4, plus c is equal to 2, and then adding 4 on both sides I get c is equal to 6. So a is equal to 1, b is equal to minus 4, and c is equal to, no, 1 second, did I do it wrong? Yes, a plus b plus c, it was equal to 2. 4a plus 2 into 4 into 1, 2 into minus 4, minus 8. 4 minus 8 is how much? Minus 4.
4 minus 8.
Hmm.
What?
And then if I add 4 to both sides, it would be c is equal to 6. Hmm. It did say a plus b plus c is equal to 2. Hmm. Hmm. Fine. Okay. Oh, that is what I did wrong over here. A plus b plus c. 1 second. A is 1, B is minus 4. Why did I put minus 8 over here? This is what I did wrong. That's what I was thinking. Again, doing this part again. A plus B plus C is equal to 2. So I'll just write A plus B plus C is equal to 2. A is 1, B is minus 4, plus C is equal to 2. 1 minus 4 is how much? Minus 3, plus C is equal to 2, and then adding 3 on both sides, I get C is equal to 5. Got it?
Yes, sir.
Next question.
It's a really long question. I think that was the last one. Oh no, that was for that page, not for.
There are a few more. Shall we do even numbers out of all these? I'll keep telling you which ones to do. So first we solve 12. Quickly, you'll solve 12 complete and let me know your solution,
Okay.
and then we'll see if you've got it right. Go ahead.
Yeah.
Answer for part A is
3x squared minus 10x plus 5 plus 0.
3x squared minus
No.
10x plus 5.
Yes.
dy by dx is equal to 3x squared minus 10x plus 5. Alright. Part B.
Or B, the points P and Q lie on C. The gradient of P at point P and Q is 2. The x coordinate of P is 3. So we know that dy over dx is equal to 2.
Hmm.
And the x coordinate of P is 3. Find the x coordinate of Q. So if you do y is equal to. Okay, yeah. So I do y is equal to. Because I want to find the y axis first, and if I can find that, or find the equation for the tangent.
Mm-hmm.
Find,
It
find
will be like this. So you said dy by dx is equal to 3x squared minus 10x plus 5. So now we know that the gradient is 2. So I say 2 is equal to 3x squared minus 10x plus 5. If I turn it into quadratic equation, it will become 3x squared minus 10x minus 3 plus 3 is equal to 0, right?
yes, sir.
Then I'll say
No.
what now?
Oh, wait. Oh, okay. Yeah,
Subtracting 2 from both sides.
yeah, yeah.
Okay, and then to solve this quadratic equation, I will have 3x squared minus 9x minus x plus 3 is equal to 0. So 3x common, x minus 3 minus 1 common, x minus 3 is equal to 0. So I get x minus 3 and 3x minus 1 is equal to 0. So x is equal to 3 and x is equal to 1 over 3. So if I am told that x coordinate of P is 3, x coordinate of P. then this implies that this one over here will be x coordinate of q.
Okay. Oh, yeah, because we are given what P is.
So x coordinate of q is how much? 1 by 3.
X coordinate. Yeah, it be 1/3 because we already know what P is, which is equal to 3. So we
So
already can say
at
that.
both points, at both p and q, the chord the gradient is 2. So if I put it for 2 and then solve for x, this x would give me two values. One of the values is at p coordinate, the other value must be for the x coordinate at q. Next part.
I can just pull up.
Hmm. No, did you note? I mean, did you get this one down?
Yeah, I got.
Okay, find an equation for the tangent to C at P.
First, I need to find what Y is for doing that. We have the gradient, we have X, we don't have Y, and we don't have C. We want to find what where M and C are the constants.
Tangent to C. So for tangent to C, we need a few things. If we need the equation y is equal to mx plus c, we need the gradient, and if at that point I put x and y, I will get the value of c, right?
Yes.
At P, x coordinate is how much?
At P, the X coordinate would be 3.
X coordinate is 3. So if I put in the original equation of the curve, x is equal to 3, I will get the value of y. I'll get both points of the coordinate P.
Sorry, what?
See, I have to find equation of tangent to C at P. So if, for example, this were the curve and I want tangent at this point over here, in order to find this point is common between the curve and the tangent, right? This is point P. Are you following me or not?
I am.
Okay, so for this point I know that x coordinate is 3. I don't know what is y coordinate. So if I put x is equal to 3 in this original equation, I will get the y coordinate also
Oh,
at this point.
oh, okay, okay. Yeah, I see. Okay,
Okay,
I was thinking of doing something else, but yeah, that
so
would work.
first I'll write finding y coordinate of P. I'll put y is equal to 3 cubed minus 5 into 3 squared plus 5 into 3 plus 2.
Okay.
So I get y is equal to minus 1.
I'm checking now in the calculator. Yeah, -1.
So y is equal to minus 1. And now I need the equation in the form y is equal to mx plus c. So m I know, m is how much? Gradient is 2. At point 2, gradient of the curve is 2. Gradient of the curve at any point is gradient of the tangent. The gradient of C at point P and Q is 2. It's given over here. So for this equation, M will have a value of 2. So I say y was how much? Minus 1
Yes,
is
it was.
equal to 2 into x was how much? 3 plus c. Y is equal to mx plus c. So I get minus 1 is equal to 6 plus c. So I get c is equal to minus 7. Understood?
Yes, sir.
Now I can say the equation of the line is y is equal to 2x minus 7.
Y is equal to x minus 7. Yeah, you can say that. But if it's just only for one, right? Does it ask for both or only one?
For just p.
Oh, for P. Okay. I thought I was asking for Q as well, which kind of confused me. But if the tangent, the coordinate at the point R and
Equation
S.
of tangent at p, it will be y is equal to 2x minus 7.
Yeah, okay.
Noted?
You just, yeah, I have. Uh,
All
no, one
right.
second. Sorry.
Hmm.
Okay, yeah, I got it.
There would have been another way you could have solved it. So for example, you could have also used the equation y minus y1 is equal to m into x minus x1. That equation could have also given me y minus y1 and x1 is the point. So y1 is minus 1, m is 2, x minus x1 is how much? X1 is 3. The point that I have, it is 3 comma minus 1, right? Are you there?
Yes, sir. Yeah, I'm here. Okay.
Did you
Just,
understand this equation? Do you know this equation? Y minus y1 is equal to m into x minus x1. This is equation
how
how I find equation of a straight line where y1 and x1 is the point given. If I'm given one point of a straight line and I'm given gradient of that straight line, I can use this equation y minus y1 is equal to m into x minus x1. Okay. All right. So if I expand this equation, it will eventually become y plus 1 is equal to 2x minus 6, and subtracting 1 from both sides I get y is equal to 2x minus 7. Same equation. So I can use I can find the equation using this equation y minus y1 is equal to m into x minus x1, or I can do it using the formula y is equal to mx plus c. Both would get me the same answer. Next
okay.
next
Oh,
question. Hmm.
okay, I see that. If this tangent interests the coordinate axis of point R and S, find the length of R S, giving your answer as a third.
This tangent intersects the coordinates R and S. Hmm. Uh, Coordinates the x's. Hmm. R and S. Okay. So we have to find where this tangent intersects the x's. So it would this 2x minus 7, this is the tangent that we are talking about right now. At one point it will intersect the x-axis, and at the other point it will intersect the y-axis, right? This tangent that we
Yes.
have 2x minus 7, so y is equal to 2x minus 7. It will intersect the x-axis and it will intersect the y-axis. So what are the points at which it will intersect the x and y-axis? For the intersection of y-axis, x is equal to 0, so I get y is equal to minus 7. When x is equal to 0, y is equal to minus 7. So one point at which this tangent it intersects the axis is 0 comma minus 7, the x and y axis. So it intersects at over here 0 comma minus 7, and I have to find this other point where else it intersects the x axis. So for x axis I will have to put y is equal to 0. When y is equal to 0, 2x minus 7 is equal to 0, 2x is equal to 7, x is equal to 7 over 2, x is equal to 7 over 2. Okay. So the second point over here is 0 comma 7 over 2 comma 0. Are you sure you're getting this part?
Yeah, I get that part because if we're just putting it back to the equation, that uh, bring it back. I just didn't know if we.
No,
Uh,
understanding the question is important. What is it that I have to find out? The tangent, the
you want to
equation of
find out the
tangent
length.
that I just found out are the tangent 2x minus y is equal to 2x minus 7. That was the equation of tangent first of all. Y
Yeah.
is equal to 2x minus 7. Now this line, it is going to intersect x-axis at some point and it is going to intersect at y-axis at some point. So the 2 points where it intersects the x and y axis, they have called those points R and S. Okay.
Okay.
The point where it intersects the x-axis and point where it intersects the y-axis. Now it is asking us to find length of this RS. Okay.
Okay. Yeah.
So in order to find the length of this RS, we will have to apply the distance formula. Distance between 2 points. What was the distance formula? How do I find the distance between 2 points? It is RS is equal to under root x2 minus x1 whole squared plus y2 minus y1 whole squared. And from where do I get this distance formula? Look carefully over here. Let's consider this is the line RS. Okay. So I can construct a right angled triangle. This is
Okay.
RS. RS squared is equal to this first one. Let me call it S1 just for no reason, and let me call this R1 over here. So RS squared is equal to S1 squared. Hypotenuse squared is equal to adjacent squared plus opposite squared, right? You sound confused. I don't think you're getting this part.
You
Just
know, I understand because something else we did
okay.
in school. We did
Hmm.
coordinated geography, so
Hmm. Hmm.
in
Hmm.
geometry, not geography. So
Hmm.
I understand this part. Yes.
Okay. Okay. So let's just leave it to this, that we have to do root x2 minus x1 whole squared plus y2 minus y1 whole squared. X2 is 7 over 2, x1 is minus 7, sorry 0. So 7 over 2 minus 0 whole squared plus 0 minus 7, so 0 plus 7 whole squared. The answer is
The answer would be no, it wouldn't be 10. It would be 4 plus 0 plus 7 squared. That would be 5. It would be 7.8. Or if in third, it would be 7 over 5. 7 root 5 over 2.
that will be the answer. That will be the length of this RS segment. Got it?
Yes.
Okay. Quickly, next question. Um,
I was going to say, but can we stop here for today?
we can, but the thing is, we have been on this chapter for